Welcome to another module of Practical Data Science course. In this module, we will cover the basics of text mining. After completing this module, you will be comfortable with anything possible in text mining. This module starts with the definition of text mining. After that, you will learn the process of text mining. Then we will focus on application of text mining. The advantages and challenges of text mining will be discussed after it. And finally, we will implement the basic concepts of text mining in Python. I guess you are very excited about this module. Let's get started. Text mining is the process of exploring and analyzing large amounts of unstructured text data with the help of software that can find concepts, patterns, topics, keywords, and other attributes in the data. It's also called text analytics, though some think the two terms are different. In their view, text analytics is the application that sorts through data sets by using text mining techniques. Sometimes, you will hear people using text data mining, or document mining, instead of text mining. No matter which name is used, they all refer to the same thing. And that is the process of exploring unstructured text data to discover useful information. Text mining is similar to data mining, but focuses on text instead of more structured forms of data. But one of the first steps in text mining is to organize and structure the data in some way, so that it can be analyzed both qualitatively and quantitatively. The initial work includes grouping, clustering and tagging text, summarizing data sets, making taxonomies, and getting information about things like word frequency and relationships between data entities. Then, analytical models are run to get results that can be used to shape business strategies and operational actions. There are no hard and fast rules to perform text mining. However, there are some common steps in text mining. The first step of text mining is identifying and retrieving relevant sets of text data to analyze. The second step is running algorithms to categorize, summarize, and organize the data. In the third step of text mining, the analytical models are used to discover ID concepts, patterns, and other attributes. The fourth step is about the application of the findings. And the fifth step is preparing data for visualization and sharing the results. In the past, NLP algorithms mainly were based on statistical or rule-based models that told computers what to look for in data sets. In the middle of the 2010s, however, deep learning models that work with less supervision started to become a popular alternative for text analysis and other advanced analytics tasks that use large data sets. Deep learning uses neural networks to analyze data in an iterative way that is more flexible and intuitive than traditional machine learning. Because of this, text mining tools are now better able to find similarities and connections in text data, even if data scientists don't know what they're likely to find at the beginning of a project. For instance, an unsupervised model could put together a group of topics from text documents or emails without any help from an analyst. A popular text mining application called sentiment analysis can track how customers feel about a company. Sentiment analysis, which is also called opinion mining, pulls text from online reviews, social networks, emails, call center interactions, and other data sources to find common threads that show how customers feel, whether it's good or bad. This kind of information can be used, among other things, to fix problems with products, improve customer service, and plan new marketing campaigns. Text mining is also often used to screen job applicants, based on the words in their resumes. Stop spam emails. Classify website content. Flag insurance claims that may be fake. Analyze descriptions of medical symptoms to help doctors make diagnoses. And look at corporate documents as part of electronic discovery processes. Text mining software also has the same kind of information retrieval features as search engines and enterprise search platforms. But this is usually just a part of more advanced text mining software, and not used in and of itself. Chatbots answer questions about products, and do basic customer service tasks. They do this by using natural language understanding, NLU, technology, a subcategory of NLP, that helps the bots understand what people say and write, so they can respond appropriately. Natural language generation, NLG, is a similar technology that uses documents, images, and other data to create text on its own. For example, NLG algorithms are used to write descriptions of neighborhoods for real estate listings, and explanations of key performance indicators that are tracked by business intelligence systems. Using text mining and analytics to find out how customers feel about a product or business can help companies find problems and fix them before they become big problems that hurt sales. Mining the text of customer reviews and emails can also help find new features that customers want, which can be used to improve products. In each case, the technology offers a chance to improve the overall customer experience, which should lead to more sales and more money. Text mining can also be used to predict customer churn, so companies can take steps to stop customers from going to their competitors as part of their marketing and customer relationship management programs. Text mining tools can also help with things like finding fraud, managing risks, advertising online, and managing web content. Text mining can be hard because the information is often unclear, inconsistent, or even contradictory. Trying to figure out what it means is even harder because of differences in syntax and meaning, as well as the use of slang, sarcasm, regional dialects, and technical language that is specific to each vertical industry. So, when categorizing, tagging, and summarizing sets of text data, text mining algorithms must be trained to understand such ambiguities and inconsistencies. Also, the deep learning models used in many text mining applications need a lot of training data and processing power, which can make them expensive to run. The inherent bias in data sets is another problem that can cause deep learning tools to give wrong results if data scientists don't catch the biases when building the models. You can also choose from a lot of text mining software. There are dozens of commercial and open source technologies that can be used, including tools from IBM, Oracle, SAS, SAP, and TIBCO, which are all big software companies. Enough talking about text mining. It is time to take things to the next level. That is implementation of the concepts of text mining using Python. Are you excited? Let's get started. The Natural Language Toolkit, or NLTK, is a robust Python package that gives users access to a variety of natural language processing methods. It does not cost anything. It is open source. It is simple to use. It has a huge community. And it is very well documented. The most widely used algorithms, including tokenizing, part-of-speech tagging, stemming, sentiment analysis, topic segmentation, and named entity identification, are included in NLTK. The NLTK library provides assistance to the computer in analyzing, pre-processing, and comprehending the written text. We will implement the text mining concepts using this library. We will use Google Colab for text mining. One of the advantages of using Google Colab is that the NLTK package is already installed. We do not need to install it. Let's create a new notebook. Then name it text_mining. Now, we need to import the NLTK library. Actually, this is the first thing we have to do. We are going to use NLTK for this lesson. Of course, we cannot do anything else unless we import it. To import it, use the following code. Import NLTK. Now, run the code cell and the NLTK library will be imported. The next task is to download Punkt, Stopwords, WordNet, OMW 1.4, average_perceptron_tagger. These words seem strange, aren't they? Of course, in the beginning, anyone will wonder what these words mean. Let's explore a little more to understand what these are, and what do they do. The Punkt sentence tokenizer. This tokenizer divides a text into a list of sentences, by using an unsupervised algorithm to build a model for abbreviation words, collocations, and words that start sentences. The stop words in NLTK are the most common words in data. They are words that you do not want to use to describe the topic of your content. They are predefined and cannot be removed. WordNet is an English dictionary that is a part of the Natural Language Toolkit, NLTK, for Python. This is an extensive library built to make natural language processing, NLP, easy. The OMW is the abbreviation of Open Multilingual WordNet. It helps to process sentences containing words from multiple language. The average_perceptron_tagger is used to tag the words of a sentence with their parts of speech. Tagging with parts of speech helps discover the relation among the words in a sentence. So, we've learned enough about these resources. Now we have to download them. To download these, type in nltk.download. nltk.download stopwords. nltk.download wordnet. nltk.download omw1.4. nltk.download averaged_perceptron_tagger. Now run the code cell and these resources will be downloaded. After these will have been downloaded and installed, the notebook will be ready for text mining coding. The initial stage in doing text mining is known as tokenization. Tokenization is the act of breaking up larger pieces of text, such as sentences or words, into more manageable units such as words or phrases. A phrase or paragraph is constructed by tokens, which are individual entities that function as building blocks. There are two types of tokenization: sentence tokenization and word tokenization. For text mining, the first skill we need is to be able to tokenize words and sentences. Let's start with sentence tokenization. Type the code with me to tokenize sentence. First of all, we need to import send_tokenize module. So, type from nltk.tokenize import send_tokenize. After that, create a variable named text. Then store a set of sentences in it. We can store: Hello Mr. Jones, how are you doing today? The weather is great. And city is awesome. The sky is bright blue. You shouldn't call for meeting today. Now define another variable named tokenized_text. Then use the send_tokenize function. And put the text variable as the argument to this function. Finally, print the tokenized_text. Then run this code cell. Here, we can see the sentence tokens. That means, this code converts the text into a collection of sentence tokens. Now, let's see how to do word tokenization. Again, we need to import word_tokenize module to do it. So, type with me from nltk.tokenize import word_tokenize. After that, create a variable named tokenized_word. And then use the word_tokenize function. The input argument to this function is the text variable. Finally, print the tokenized_word. This particular code snippet decomposes the text into word tokens. Run this code cell. And we can see word tokens. Once tokenization is completed, we can find out valuable and useful information from the tokens. Frequency distribution is one of these. To find out the frequency distribution, we need to import the freq_dist module. To do it, code with me. From nltk.probability import freq_dist. After that, define a variable named frequency. Then use the freq_dist. This function requires an argument. In our code, it is tokenized_word. Finally, print the frequency. Here, we can see the frequency with 25 samples and 31 outcomes. It is showing the overall distribution. Sometimes, we do not need the frequency distribution of all words. We need to know the frequency of most common words. For example, say that we need the frequency of the 3 most common words. In this case, we need type frequency.most_common. And then use 3 as argument to this method. To mine valuable information from the text, sometimes we need to take the aid of visual representation. For example, the graphical representation of the frequency distribution uncovers more information than numeric output. To show the frequency distribution graphically, we have to use the matplotlib library. Let's write the code. Import matplotlib.pyplot as plt. After that, frequency.plot and the arguments are 30, and cumulative equals false. Finally, use plt.show to display the result. Now run this code cell. And we can see the output. Here we can see the word is has the highest frequency. After that, the words today and the have the second highest frequency. The frequency of the remaining words is 1. There are words in sentences that do not play any role in text mining. These words are called stop words. Usually, am, is, are, this, a, and, the, etc. are considered as stop words. However, depending on the goal of the text mining, different words can be considered as stop words. Let's write the code to find out the stop words. Now, code with me. From nltk. Corpus. Import. Stop words. After that, create a variable named stop_words. Then use the set function. The argument to this function is stopwords. It takes another argument, which is the language. We are using English here. Finally, print the stop_words. Here, we can see the stop words. The purpose behind finding the stop words is to remove them. Let's see how to do it. Define a variable named filtered_sent. Then make it an empty list. After that, use say for loop. Type for w in tokenized_text. Then use the colon. Now, we are inside of the for loop. Here, use an if condition. Then type w, not in, stop_words. Then use another colon to enter this block. Here, type, filtered_sent.append. And use the w, as the argument. Finally, print the tokenized sentence and the filtered sentence. Now run the cell and here you go. We can see the outputs. Another essential operation in text mining is lexicon normalization. The lexicon normalization process takes into account another form of textual noise. For instance, the words connection, connected, and connecting may all be condensed into the single word connect. It does this by reducing all of the derivatively related variants of a word to their common base term. Usually, there are two ways to do lexicon normalization. They are stemming and lemmatization. Stemming is a linguistic normalization technique that either reduces words to their root word or cuts out the derivational affixes. This process lowers words to their root word. For instance, the words connection, connected, and connecting may all be condensed into the single word connect. Let's write some code to do it. Type from nltk.stem import porter stemmer. After that from nltk.tokenize import cent_tokenize word_tokenize. Now create a variable named PS, or anything else you want. Then assign the porter stemmer function to it. After that, use another variable named stemmed_words, and make it an empty list. Now, need another for loop. Type with me. For, w, in, filtered_sent. Colon. Then, stemmed_words. Dot, append. The input argument is PS, dot stem. And W is the argument of it. Finally, print the filtered sentence and stemmed sentence. Now run the code cell. Here we can see the filtered sentences and stemmed sentences. Alright. We've learned word stemming. Let's move out attention to lemmatization. Lemmatization is the process of reducing words to their root word, which are the lemmas, that are correct linguistically. It does this by employing techniques, such as vocabulary and morphological analysis, to change the underlying term. In most cases, lemmatization is considered to be a more advanced process than stemming. The stemmer analyzes each word on its own, without taking the surrounding text into account. For instance, the word better derives from the word good, which serves as its lemma. Because it needs looking anything up in the dictionary, this object won't make it through the stemming process. For lemmatization, code with me. Type from nltk.stem.wordnet import wordnet lemmatizer. Then define a variable named lem and store wordnet lemmatizer function in it. After that, from nltk dot stem dot porter import porter stemmer. Now, declare a variable named stem. Then store the porter stemmer function in it. All set. It is time to see how it works. Let's use a variable named word and store working in it. Then use the print function and type lemmatized word. After that, the lem dot lemmatize method. And pass the word and v as the arguments. Now use another print function. Let's write stemmed word, colon, in it. Then separate it with a comma. After that, type in stem, dot, stem. Then pass the word as its argument. And run the cell. We can see the lemmatized word, stemmed word. Now copy this portion and paste it here. This time, change the word to flying. Run the cod cell again. This time, we can see the lemmatized word is flying and stemmed word is flee. We are making good progress. We've almost covered the basics of text mining. The last thing we are going to learn is pos tagging. Identifying the grammatical category that a particular word belongs to is the fundamental objective of the part of speech, or pos tagging system. The context will determine if it is a noun, a pronoun, an adjective, a verb, or an adverb, among other things. Pos tagging examines the context of the phrase to identify potential connections between the words, and then applies an appropriate tag to each one. To do pos tagging, first of all, we need to tokenize the sentence. Now code with me. Declare a variable named sentence. Then store some string there. For example, Albert Einstein was born in Ulm, Germany in 1879. Now take another variable named tokens. Then set the NLTK word underscore tokenize method with the sentence argument. Finally, print the tokens. We can see we've successfully generated the tokens. Now we will use the pos underscore tag method to find out the parts of speech of the sentences. After tokenization, the tokens are passed as the argument of pos underscore tag method of NLTK package. Here is the code. NLTK pos underscore tag. Then pass the tokens as the input argument of this method. And run the cell. We can see the tokens and their corresponding parts of speech. Here Albert is NNP. NNP stands for proper noun, singular. Einstein is also a singular proper noun. That means NNP. The was here is VBD. The VBD stands for verb past tense. We can see born is VBN. It means verb past participle. So, this is how we can discover the parts of speech of the words in a sentence. Text mining is a very large field. If you learn the basics operations of text mining, explained in the implementation section, you can do anything possible in text mining.